so the next thing we're going to do is introduce our Building Better team. And just before that, the art that we've all been a part of, we need to make sure that we thank Matt Colleget, who was from the University of Akron but could not be here. He had a big part of creating the art. And also Chris Maurer was the energy behind getting this art here. And now I will introduce Chris. Take on the next session.
Hey. Good afternoon. Hope everybody got ice cream and cookies and coffee and it's enough sugar to power us through. The next section is going to be called Building Better and how can we learn from biomimicry in building. So nature builds sustainably, but humans do not. There was a time where we used to be more in tune with nature before the advent of the agrarian revolution that kind of made sedentary lifestyles. That pretty much coincides with the invention or the discovery, I guess you could say, of architecture. And, ever since then, we've kind of lost our way. But the architects that are going to be speaking to us now are going to see if we can't find our way back to that garden where we used to live, where we were more in tune with nature. And some of the solutions will look at, structures in nature and try and relate those to structures of architecture. Some will look at organisms and how they build. And some will actually talk about growing like an organism. So, biomimicry in total, basically, the idea that a building could be an organism and can grow. So with that, I'll introduce the first speaker. Hans Papke is the principal of DLR Group. They did 2,800 projects last year. So they do a lot of work. And so implementing biomimicry at a scale like that would be phenomenal for this planet and for all of us. He's going to talk about buildings that learn from the structures found in nature, and I'll hand it over to him. Thanks, Hans.
Thank you, Chris, and everyone, thank you for having me. My name is Hans Papke. I'm an architect and lead sustainable practitioner in the Southwest region in Arizona. Something that really got me into sustainability and biomimicry is a stat that I heard a while back that 40% of all global greenhouse gases come from the built environment. And that hit me really hard. And as an architect, it's my duty to build better buildings for not just the humans on the planet, but for the planet itself. And it's also our duty to help reduce that number down. I know that if we continue with this path that we are on, that number is going to double by 2050. So we really need to start looking at the built environment. And I'm going to go through the process of one project that I've done recently, looking at sustainability on the project. I'm going to walk you through my design process. So it's a little different than what we've heard earlier today. But I feel like if every architect or every person that enters a building can understand the whole process that we go through, we can all understand the buildings we're in, how they function, and why us architects are doing what we do. So the Pinal County Attorney's Office is a project located in the desert of Arizona. It's about an hour east of Phoenix, Arizona. I had a client who did not care about sustainability, and it's a government client. And it really breaks my heart to hear the government spend so much money on projects and they don't care about the built environment. They don't care about sustainability, but I do. So I forced it on the project, and I made it under budget, actually, as well. So with this project, some background on it. It is a 5-story building, 55,000 square feet. It's located next to an existing courthouse. I'm going to jump back a slide. You can see it in the back corner. It's a very brutalistic building because that's how they build in the desert. They try and build very thick walls, punched openings in random spots to allow minimal daylight. And I really wanted to flip the script on that and do something completely different. Some of the design principles that I come up with on every project, I derive from the user itself. So I sit down with the user for a long period of time, come up with some design principles. These are the design principles we came up with on the project that allow me to articulate their ideas into a building. So the main ones, architecture needed to relate to the type of work that happens. It's an attorney's office, so they needed to look powerful, but also have an authority figure needed to connect to the public. It is a public building, so we needed to reach out to the public and make sure that the public knows that it's for them. It's their money that they use to build this building. And then the architecture needed to be modern and different. This project, or this, is located in a county that's away from the major counties of in Arizona. So in order to attract the best and brightest young attorneys, they needed a building that had new amenities, wellness, and be modern looking and feel to entice them to want to work there. So first I was given the problem. I was mentioning to someone earlier today that as an architect, I don't see myself as a builder or a designer. I just see myself as a problem solver. And the problem that they gave us was, let me see if I can get the pointer to work. We have a courthouse here, and then we have a jail on the right, and then we have this blue area, and that's where they wanted us to build the building. So we started to dive into the program and looking at the project and realized that there's so many complexities to this that it didn't make sense to build the building there. One thing we look at with sustainability is what I call right siting and right sizing. So I need to make sure the building sits on the site correctly in its orientation to help reduce solar heat gain, accentuate the natural daylighting, simple basic tactics, but also right sizing, which is looking at the building and making sure we're not overbuilding this project, wasting space, wasting area that needs to be heated, cooled over time. So at DLR Group, we have a high performance design team, and I leverage this team on every single project I have. These are some of the complexities of that site. I'll jump back. There's a bunch of vehicular areas, mechanical areas, and in order for me to build a 5-story building in that spot, I'd have to build it up on stilts, and it became more complex. So I had to convince the client that building a building on that part of the site was not possible, and if it was to be there, it's going to be more expensive, not only to construct it from the beginning, but also the life cycle costs were going to be higher due to its orientation and location. So these are just some of the stats that I use with my high performance design team to look at daylighting studies and energy modeling. We did several iterations, and then I looked at actually flipping the building to the opposite side of the courthouse. It needed to be connected to the courthouse. And this was in a parking lot that was an off-limit zone for me, but I figured if I can present some data to them that would actually save them money over the long haul of the building, they might bite on it and allow me to build the building there. And as you can see on this last diagram, with the daylighting studies, we are getting low daylighting to the center of the building, but ideal daylighting to the perimeter of the building. And so as we started to do this with this data and analysis I was able to present to the client, they said, let's go for it. Let's build it on this side of the building. So battle number one is won. This is the overall site plan of how it connects to the courthouse. Battle number two for me was, how do I get this building to sit into the landscape and not just become, another building that's erected that you can put anywhere? I have a strong belief that architecture should grow from the earth that it's from and look as though it's part of the earth. With a 5-story building in the middle of the desert, and the next tallest building is the courthouse next to me, and the next tallest one to that is only a 2-story building. So this thing was going to be really tall in the desert, and I needed to find a way to really connect it to the desert. I'm an avid backpacker. I backpack a lot around the country, multiple times a year. And so I set off to do some hiking around the site, and I slowly started to see that in some rock formations, there's the shade of the rock formations was growing plants, vegetation, flowers. And I thought, wow, that's really interesting. Could I create a building that has these pockets of shade to allow people to enjoy amenity spaces outdoors? And then I started to look at the saguaro cactus. The saguaro cactus is probably, I think it's the tallest cactus in the Sonoran Desert. It only grows in the Sonoran Desert, and it takes about 100 years to grow as tall as this medium-sized one. So you can imagine some of these other ones with the arms are well over 400 or 500 years old. As I looked at the saguaro cactus, it had vertical ribs on it, and it's round. And as the sun passes around the saguaro cactus, it started to self-shade itself with these vertical ribs. And so I thought to myself, can I create a building in the desert that's vertical out of the ground, but also become a self-shading building? So it's not so obtrusive to the landscape, but it's actually protecting the building as well. And so that's where the battle number 2 came, is trying to come up with a design concept for a building. And I looked at biomimicry and mimicking the saguaro cactus in its self-shading properties, and started to develop strategies on how I can do that on our building. We also started to look at money and where you put money on a project. And this is very important because all projects have budgets. And when you're looking at sustainability and you're looking at doing something completely different, clients usually run away from it. They don't want it. Like, this client did not care about sustainability. So I said, if we have this budget, where can I put the money that gives us the most value? And so this is just a little diagram of where we thought we could put the money spent. So on the east side, we're up against a courthouse. We don't need to spend much money there. We're 6 feet off of it. The southern part of the building receives the most sun. I want to put some money there, but not too much. The west facade actually abuts a highway, so I really wanted kind of a wow feature there. And then on the north side, it looks off to the Superstition Mountains, which are glorious purple mountains, and I wanted to make sure we get natural views out to the mountains. So this goes, as I'm looking at the concept of the exterior, I'm also looking at right sizing. So what this diagram shows is I work with my mechanical engineers. I have an integrated design practice where we have mechanical, electrical, structural, acoustics, lighting, all in-house in my firm. And we work together as a team from day one. They're part of my team to understand how to build the building and be smarter with what we're doing. So we start to look at reducing plenum spaces where all the lighting and mechanicals housed. Typically that's 4 feet. We try to reduce it down to 2.5 feet. So I have to work back and forth with that team to reduce that. We looked at working with the overall footprint of the building. If we can start to shrink some of the office space down, we can reduce the building by a certain percentage. So most offices have door swings that swing into the space. We decided to go with a barn door. That way the door doesn't swing into space, and we were able to save 1.5 feet of each office. So that helped reduce and shrink the whole footprint of the building. As you can see with the diagram, when we shrink the whole building, you shrink the whole envelope, which reduces the whole construction costs as well as the building materials you're using. So you start to look at the carbon footprint that this building has, and we're starting to reduce it slowly just by doing simple things with reduction of the interior space, wasted space. As you can see with these diagrams, it's very office-driven. Attorneys like to be in their offices. So they want perimeter office space. So it's hard to get natural daylight deep into the building when you have perimeter offices. What we proposed on the project was every single office was glass, floor to ceiling, that went to the corridor. This way, the natural light from the exterior can go through the office and into the corridor. And back with the energy model, you saw that it was ideal lighting all the way to the core space. So we put all the core of the building on the inside, the egress stairs, the restrooms, the elevators, the print rooms, most of the non-occupiable spaces at the core. This building can actually function with no artificial light, and everyone has the right foot candles at their desk at the end of the day. And that was a goal of ours to hit. You can also see with landscape around the building, over here, we look at the solar heat gain on the building from parking lots and surfaces like asphalt, concrete. And if we can actually produce landscape, a 30-foot buffer around the building, we can reduce the total solar heat gain on the building by 25%. So looking at the type of vegetation we can add around a building to reduce that is very beneficial. One note I'd like to make is it's a really cool idea. There's this courtyard over on the southeast corner of the project. That's actually a fire lane. I work really closely with our sustainable landscape architect, and we need a fire lane for all these buildings, and we came up with a clever idea of creating a plaza area with grass, and it's called Grasscrete, that a fire truck can actually drive on at times. We're hopeful that the building never catches fire, so it's never used as a fire access lane other than 2 times a year for testing. But this was another way to add some greenery and soft space and help reduce solar heat gain on the buildings around it. Typically, that space would be a gravel space or asphalt. In this case, we made it a plaza for the employees to go and hang out. These are some of the renderings we came up with early. The north side of the building is all glass. We've got a lot of feedback early on the project when I did some community outreach that why are we building a glass building in the desert? This glass is on the north side of the building, so you're not getting direct sunlight except on the summer months at the very beginning of the day and the very end of the day. But with technologies, we use a solar band 90 glazing on the north side, which allows, the solar heat gain to reduce on the glass, but also gives us those stunning views to the mountain range north of there. And then the rendering on the far right is the southern part, where you can start to see the facade of the building. There's punched openings in it, and at every punched opening, we decided to put a fin on the building. The fins become part of the solar heat gain reduction, and they self-shade the building. I'm gonna have to fly through a few of these, but here's some construction photos of the fins. These fins are about 4 feet wide by 19 feet tall, very massive. There's 120 of them on the project. When we started looking at the west facade against the highway, the desert itself, it blooms once a year and has these spectacular colors in the saguaros, cactus bloom, as well as on the surface ground. So we looked at how can we create a facade on the west side that has a pop of color to it, but only happens at like a fast pace. So as you're driving your car down, imagine if you're going from left to right, you're driving your car past the building, you barely see any color. As you get to dead on center of the west facade, you get this really pop of vibrant color, and as you drive away, it dissipates. So it's a poetic move that we did just to represent that quick pop of color that the desert gives us once a year. These are just some final photographs showing the shade fins and how they work. You can see at this bottom center image how the shade fins start to cast shadows back onto the building, which help reduce the solar heat gain. But then the panels themselves are also ribbed. So you can see a lot of the metal panels. Metal absorbs heat. And one thing we're doing to help reduce that is have other ribs in there to create other shadows and other valleys on the project. Then we also pulled the metal panels away from the building to allow convection to come up through the building before it hits the building to reduce that solar heat gain. And then at each level, kind of like tectonic plates as they shift, that's how the structural system worked on this project. But there's gaps, and that's where that heat would escape and go away from the building. And I'll go to one more slide and leave you with this. But that is the Pinal County Attorney's Office, and I looked at the saguaro cactus self-shading plant in the desert as my inspiration to design the project. So thank you.